Hello, welcome to MathLux. This is a video on end behavior of polynomial functions. So a polynomial function takes the form anx to the power of n, and then an minus 1 times x to the power of n, and so on until it's a1 times x to the power of 1 plus a0. And it should be noted that this is where an is not 0, and n is an integer value. And so end behavior describes where the function will be as it approaches positive and negative infinity. So in here, you see two graphs. The first one is a parabola, and it goes from quadrant 2 to quadrant 1. So at negative infinity, it's in quadrant 2. At positive infinity, it's at quadrant 1. And then on the next one is a cubic function, and the end behavior is quadrant 2 to quadrant 4. So you can see at negative infinity, it's quadrant 2. When x is really negative, this function is in the second quadrant, and when x is really positive, it is in the quadrant 4. The function is in quadrant 4 when x is really positive, as it approaches positive infinity. So to determine the end behavior, we need to examine the leading coefficient and the degree of the function. The degree of the function is even or odd, alright? So in example 1 here, we can see that the a value is negative, meaning that it is a function that is reflected over the y-axis, and we see that the degree is 3, which is an odd number, and that would make the degree of the function odd. So this example, we've determined those two values, and we'll graph them later, but I just want to show you what those two values mean first. And then in example 2, we can see that this function's slightly more complex. We take the degree of the leading coefficient, just the leading one, the highest degree function. Ignore this degree 1 here, it's not important. You look at the highest degree term, which in this case is 3x squared. So we know that the degree is even, and we know that a is positive. And so using these, we can look at these 4 different scenarios. For a polynomial function, there's 4 possible end behaviors. That is it. And with those two values, it corresponds to one of these four things here. And using them, we can find the end behavior of the polynomial function. So this instance 1, we'll call it, is a is positive, the degree is even, the end behavior is quadrant 2 to quadrant 1. And then instance 2, a is negative, the degree is even, the end behavior is quadrant 3 to quadrant 4, right here. And then here we'll call it instance 3, and this is where a is positive, but the degree is odd, and this is quadrant 3 to quadrant 1. And then lastly would be instance 4, and that will be when a is negative and the degree is odd, the end behavior will be quadrant 2 to quadrant 4. So now knowing this, we can go back to the previous examples, example 1 and example 2, and we can find the end behavior, right? So example 1, we determined that it was an odd degree function, and that the a was negative. And what one would this fall under? Well, it would fall under, we can see a is negative, degree is odd, we know it's instance 4. Okay? And that would mean that when we graph it, its end behavior would be something like that. Quadrant 2 to quadrant 4. Now, don't worry about graphing these with the roots and such. Obviously, I didn't draw a cubic function because it changes. Don't worry about that. That's something that we're going to be approaching in future lessons. But for this one, just worry about the end behaviors. Don't worry about graphing the functions themselves. Just find the end behaviors. And then example 2, right? We know that the degree is even and that a is positive. So what one would that fall under? Well, we know what it would fall under. We can see positive, even, it's going to fall under instance 1. Okay? Instance 1. So, yeah. Right? Positive, even, instance 1. And behavior means is quadrant 2 to quadrant 1. Let's draw that a bit nicer. I guess we'll box our answers too. Alright. So now that you know how to find the end behaviors of polynomial functions, I would like to see you do these 3 practice problems. So, pause the video now, complete the practice problems, and I will show the answers in 5, or I will start doing the answers in 5, 4, 3, 2, 1. Okay? So question 1 here, we know that x is to degree 1, which means the degree of the function is odd, because 1 is an odd number. And then the coefficient of a is 16 in this case. It's positive 16, so it's a positive function, right? So an odd degree with an a value that is positive, what does that give? What end behavior does that give? It gives, pardon me, the end behavior is quadrant 3 to quadrant 1. I guess I should note, when you're saying end behaviors, you kind of read the graph from left to right. So you don't say quadrant 1 to quadrant 3. It would be quadrant 3 to quadrant 1. Alright, on to the next example. The degree is even because you take the degree of the leading coefficient, which is, in this case, 10, and the a value is negative because a is negative 3. If it's positive 3, it would be a positive value. And if the end behavior is even and negative, then it takes the shape of instance 2, which would be end behavior of quadrant 3 to quadrant 4. Alright, now this one's a bit different to find the end behavior of, because it's not in standard form, it's in a factored form. The polynomial is in a factored form. This means that we still need to find the highest coefficient degree, though. And to do that, we would expand. Obviously, expanding this would take a long time, so let's just kind of expand the x's, is what I like to say. So you see that this is degree 1, degree 2, and degree 3. Using exponent laws, we can multiply these, or add them in this case, and we get degree 6. And that would be even. So if you expanded this, which you're welcome to expand it, but for the time of this video, we will not have time to expand it, you can see that it is an even function. If you expanded it into standard form. We just essentially counted the x's and put them to the right degrees and added them. And then, of course, no negative x's, which means that the ax would be positive. That does get a bit confusing, but with some practice problems you will begin to understand. Maybe, I guess, expand a few of these as practice. So an even positive function, we know what that would do. Right? It would go end behavior of quadrant 2 to quadrant 1. Alright, so I hope you now understand the concept of end behavior of polynomial functions, and in our next video we will be going over how to graph these polynomial functions with their roots, so how to factor them, and yeah, so I hope this was helpful. If it was helpful, leave a like to support it. Thank you. Have a good one.